Okay, amazing. Thank you everyone so much for coming and braving what sounded like quite the crowd to get up here on our 5th floor office here at Arthur HQ. We're very excited for this conversation, and I have the personal pleasure of at least saying everyone's name and titles for you so you know who you're going to be hearing from. Without further ado, since I know we're wanting to get started, we'll first have a brief word from 2 partners at Latham & Watkins, Ellie Curie, and Michael Rubin. So I'm going to pass it off to them. They'll speak for about a couple minutes. One more introduction after that, and then I will set up our fabulous panelists for you. So with that, Ellie, here you go.
Thanks. So I always wanted to be introduced as, and now a word from our sponsor. So I'm a partner at Latham & Watkins, one of the largest firms in the world, but I'm a startup lawyer. So represent companies early stage through seed all the way up. Joined about a year ago from Fenwick. And one of the things I noticed about this firm that makes me really excited. So we are constantly Tech Law Firm of the Year, constantly Tech IPO Law Firm of the Year, fabulous litigation practice representing some of Expa's portfolio companies. And we have sort of the best in class in all the geeky spaces like AI and fintech and crypto and digital health. And, I don't understand all that stuff. I'm just a startup lawyer. So I want to bring up my partner, Michael, who's one of the world's foremost authorities on AI.
That's a big title, but it's great to see everybody here. I have been working, dropping my glasses, showing my geek right here too, but I've been working in the AI space for years, long before the Gen AI broke out with ChatGPT coming on the scene in the fall, representing companies in advising, in litigation, in regulatory investigations. We really understand how this all works. I'm excited to hear what this incredible panel is going to tell us about the nuts and bolts. As Ellie mentioned, we're a large place. We represent companies around the globe. So we really understand the regulatory space, the oncoming onslaught. The LLM space is incredibly interesting, whether it's pre-trained models, whether it's the fine tuning, whether it's the layer on top, and what the regulatory space is now going to be doing to try to shape all of that. So we're excited to hear what's coming and excited to take this ride with everyone. Thanks, everybody.
Thank you. And thank you graciously for sponsoring this event, because clearly no one is interested in this topic. Next, I want to give the floor for a brief minute to Dylan Itsikovitz from Expa, who is also one of our partners. Over to you.
Yeah. Hey, everyone. 5 seconds. You all know what VC firms are, but I work for Expa. I'm based in New York. We were started by Garrett Camp, the founder of Uber. We incubate businesses and we invest in early stage companies, pre-seed, seed, Series A. And my bosses would fire me if I did not ask all the founders in the room to come talk to me afterwards. Thanks for putting this on with us.
Thank you. Thank you. Now for the fun part. Let me briefly introduce myself. I'm talking to you and you're not sure who I am. My name is Victoria Vasilova, and I was lucky enough to join Arthur 3.5 years ago almost, leading our go-to-market team. So if you have any questions, because my bosses would be mad at me if I didn't mention this, if you want to take AI performance, explainability, fairness, we're all here and excited to engage in those topics, especially as they intersect with large language models, which we're going to talk about the future of, because they've been around for so long. We can really posit confidently about this. But tonight, to get into our panelists here, so we're lucky enough to be joined by Alex Conrad, who's going to be moderating this conversation between these 4 folks here. We've got Harrison Chase, who's the CEO of LangChain. Maybe you've heard of them. Angela McNeal, who's CEO and co-founder of a self startup and formerly of Palantir. Bob Van Lout, who's the CEO of Weaviate. Yes, the Dutch pronunciation, correct. And then finally, our own beloved chief scientist, John Dickerson, also Arthur co-founder, participating in the panel as well. So with that, everyone, I hand you the microphone. Give your own, in your own words, a little bit about your bio and your backgrounds, and then Alex will take it from there with some questions. Alex, over to you.
We're gonna go up on stage? Or? All right, I'll go there. All right, it's okay. This one? Sure. All right. Okay, I think I'm mic'd. All right. Hey, everyone. I'm Alex Conrad. And I'm a senior editor at Forbes. I've been at Forbes for over a decade now, which is crazy. I initially was writing about New York startups, now spending a lot of time writing about AI startups. I prefer if they're in New York, because I'm long New York, but all over the world, and also venture capital. I run the Midas list at Forbes of top VCs chasing AI companies. And it's such a pleasure to be with, four much smarter people than me, who are at different stages of their startup journey, but all can talk a lot about the state of LLMs and sort of what's really fun here. I think we do have one mic, so we're gonna have to start by maybe going down the line, but then I'm gonna encourage you guys to just aggressively reach, kind of signal to each other for the mic. But John, why don't we start with you? If you could just give a sentence on sort of like, where you're spending the most time in the context of an LLM conversation, and ground us there, and then we'll go down and then we'll jump into some of the fun stuff. Okay?
Sure, yeah. So I'm John Dickerson, co-founder and chief scientist here at Arthur, also on leave from a faculty role at the University of Maryland. So wearing a couple of the nerdy AI and ML hats there. And when we think about LLMs, we tend to think about two things primarily. One is security, so that's protecting user experience when dealing with an LLM-based application or foundation model-based application, as well as protecting brand, right? So there's risk to brand for, toxic content being buried or sensitive data being leaked. And two would be on the evaluation side. So you'll hear more about this from all of us, as well as from Jonathan Frankle when he speaks with our CEO, Adam Wenchel, next. But evaluating LLMs is tough. And so this is something that a lot of customers currently struggle with, and this is something that I think the field in general needs to come to terms with as well. So security and evaluation are the two big ones.
Awesome. We'll just go down the line. So LangChain, which apparently everyone's heard of. So tell us why.
Hey, my name's Harrison, CEO and co-founder of LangChain. We're a developer framework, or we're a company founded around the open source developer framework that is aimed at really making it as easy as possible to build applications with large language models. And so LangChain started off, basically, I went to a lot of events like these and chatted with folks who were building applications, saw some common abstractions and factored them out into a Python library, started as a side project and kind of has gone from there. Basically, I think the general premise is you've got these large language models, which are an incredible new transformational piece of technology, but there's actually a decent amount of kind of like other things that are needed in order to build the final applications. And so we help with a lot of that orchestration and putting everything together.
Awesome. And then next we have our stealthiest panelist, Angela. Angela, just very broadly speaking, what kind of framework are you bringing to this conversation?
So hi, everyone. My name is Angela McNeal. I'm a co-founder and CEO of a startup. Yes, currently in stealth. But prior, well,
The
you're a customer.
VCs,
Remember,
the
you're a
VCs
customer,
are already
Bob. I'll
inching
give you
towards the
something.
stage. Yeah.
Yeah, that's the contract right now. But before starting this new venture, I spent the last 6 years at Palantir, where I ended my career there as the head of AI product for their Foundry platform. So I spent a lot of time focused on operational systems. So how do I think about infrastructure to support all different kinds of AI workflows, spanning from large scale computer vision systems to large NLP problems. And I spent a lot of time focusing on the operational side of things. So what do long-lived, long-running, impactful AI-powered workflows look like?
Awesome. Bob, take us home.
Hello, I'm Bob. I'm one of the co-founders of Weaviate. So it's an open source vector database. And we actually started with like TLLMs, so the tiny language models. So, no, it isn't. Oh, I should. Yeah.
It's a really good term.
So I always like to say that. So the idea started actually with Glove. So the idea that you had like, hey, wait a second, we can, express things in vector embeddings. And hey, if a vector embedding is a new data type, then probably there's going to be a database that's going to deal with the data type. And there's much more to say about that, but I think I'm going to leave it at that. But then we were like helped by the amazing research that made that T into an L. And that, those models still, they still poop out the embeddings. So that's good, right? So that's what we store. And there's like a lot of exciting stuff happening there. And we're probably gonna talk about that as well. But you know, the vector database is part of infrastructure that you might want to use for, you know, what we call your AI native applications. So that.
Awesome. I cheated on my own mic. So I think to talk about where LLMs are going, we gotta give a little context to the state of play from you experts who probably know better than a lot of us here. Maybe starting with Harrison, and then please just jump in. What would you say is kind of the most exciting change in sort of where we're at with LLMs in recent months, besides the hype? You know, obviously the energy and excitement feels newer, you know, in recent times, but what from maybe your perspective is actually new and different, maybe from the capability standpoint? And feel free to also push back and say where people maybe are getting it wrong or have the wrong idea of what an LLM actually does right now.
I mean, I think the most exciting thing that's come out recently is the OpenAI like functions calling thing. I think that came out like 2 weeks ago, 3 weeks ago, something like that. And I think the really impactful, there's two really impactful things there. One is, and for those of you who aren't familiar, you can basically provide a list of tools or functions that it can invoke, and then it is basically fine-tuned to invoke those with specific parameters. And so one, like I think a lot of the applications that we see at LangChain are not just like calls to language models, but calls to language models that then the output is used to do something. And that often comes in the form of like tool invocations or function invocations. So it's very good for that. And I think that's very impactful because I think if you hear about a lot of like agents are basically using a language model as a reasoning engine, which decide to do things. So now you've got this fine-tuned model that is fine-tuned to reason about what to do things and output things in a specific format. And building on that, like the outputting things in a specific format is also really impactful by itself. Like putting aside kind of like choosing which tool to use, there's been a lot of kind of like work gone into what we call kind of like output parsers in LangChain and a bunch of related things, which are basically formatting the output of a language model in a specific format so that you can do something with it later on. It's not just a text, there's some structure that you've got in it. And this makes it really easy to do that. And so I think that was really exciting. There's been kind of like advances similar to that in the open source. So there's been JSON Former and Realm, which are kind of like open source alternatives to that. And I think the idea of basically passing in some type of like context-free grammar that the LLM is then kind of like required to output is really exciting because, yeah, I think the power of these things comes when you hook them up in conjunction with other things, and that often, you know, means the output isn't just a string, it's a structured thing, and so structuring that is more important. So yeah, OpenAI functions I think is really transformative. I think a lot of other kind of like model providers will do similar things. There's also been kind of like similar advances in the open source. So just structuring output in general, I think is really impactful recently.
That's awesome. I know you guys have a horse in the race, at least some of you, but maybe John, could you zoom us out just a little bit with sort of where exactly you see off the shelf uses maybe not being enough and sort of like that maybe set that scene of sort of fine tuning versus, you know, using vector databases uses, you know, versus just leaning on, you know, OpenAI or someone to do it all?
Yeah, that's a great question. And one, so Arthur, you know, our blood has been for a long time a focus on enterprise. And so we've obviously expanded over the years, but many of our longest customers are very large enterprises, you know, Fortune 100s that you would know about. And a lot of these are in highly regulated industries, think like banking or think like healthcare. And for those, sometimes you're going to want to know exactly what data went into the model that you have. You're going to want to know exactly what guardrails you can have around that model. You might have particular, you know, hardware constraints because you might have to host it either, you know, within your own VPC or like actually on-prem, which, you know, TLDR, you know, this is still sort of maturing into best practices there. But there are, I would say, first off, in highly regulated industries, there's this need sometimes to either train your own or, you know, really like fine tune down to the point where you can kind of understand exactly what's going to go wrong with particular LLMs. I think you mentioned fine tuning versus vector databases, for example. You know, Bob obviously, I'm sure, has very strong opinions about this as well. But yeah, I mean, so when we personally, you know, when we talk to customers, we're seeing a lot more on the augmented retrieval side than we are on the fine tuning side. So this is often using a base model and then connecting to either a vector database or just like a traditional database even to incorporate either private data or, you know, more recent data than was actually incorporated into the LLM that you're using. I think we'll probably see more fine tuning occur. But, and you'll hear more about this from Jonathan Frankle later today, there's a lot of nuance in actually formatting and collating data that goes into even fine tuning a model. And so many customers just aren't at that level of sophistication quite yet. And so as sophistication begins to sort of increase in this space, my guess is we'll see some more fine tuning occurring, or fine tuning obviously in conjunction with augmented retrieval.
Does, just show of hands in the audience, I assume everyone here has played with an LLM, but is everyone following what this group means by fine tuning? Nod or raise your hand if you know what that means. Okay, so most people, cool. Bob, could you maybe jump in from sort of your perspective on sort of where the fine tuning limits are, sort of how this gets to a useful end result for, let's say, an actual business?
Yeah, so I can. So, but before doing that, just if I may, just a way how I look at it is that the model is stateless. Right, so the model is trained. So everybody who has used ChatGPT knows that the model sometimes says like, because it's somewhere in the prompt, right? So it says like, I'm trained in 2021, so I don't know the answer to X, right? So we have this problem of, the model being stateless. So now the question is like, bless you. So the question is like, how do we make it stateful, right? And now we have like two options at hand what we can do. So one thing that we can do is that we can fine tune. And so we can say we're going to give more information to fine tune it. So let's take an example that if you take a generative model and you say like, where's the Eiffel Tower? Then the model is going to say it's in Paris. But what if we want to give it something that we say, well, the example we always use internally is like, we loaded the Eiffel Tower on a truck and we drove it from Paris to Berlin, right? So how do we do that? How do we solve that problem? And the option one is that you fine tune. But the problem with fine tuning is like twofold. So the first one is that that takes a long time. I mean, Jonathan might disagree with that, but relatively, it's like if you want to use it in a real-time application, that takes a long time. And secondly, it might still hallucinate, right? So it might still say like, yeah, it might be in Paris, but also in Berlin now. So one thing that you can do with a vector database is that you can say like, well, we're going to inject that information into the prompt, right? So we're going to say, okay, the question is like, where's the Eiffel Tower? And we've stored in our database that it's in Berlin. So we inject that in the prompt and say like, you must base your answer on whatever information we're giving you. So to your question, I see fine tuning being used not for knowledge representation, but I see fine tuning being used to augment the way that the model interacts with you. So let me give you a very pragmatic example. Let's say that you fill a vector database full of, I don't know, beauty products, and you fine tune the model on texts that are coming from beauty influencers, like text from YouTube. Then what you can do is you can create a chatbot that operates and speaks and talks in the speak of like an influencer, beauty influencer, by fine-tuning it. But the knowledge that it has is injected to the vector database. I hope that makes sense. But that's like how you try to make the stateless model stateful. All right, so that's the thing there.
Yep.
One of the things that's been on my mind recently, and I'm curious what your guys' perspective are with respect to fine tuning. A lot of the APIs that currently exist, the fine tuning APIs for large sort of model shop providers are, upload your data, run your training jobs, and then you have your nice endpoint that you can interact with. But you actually don't own the rights. You can't download that model. You don't own the rights to those weights, right? Or, I guess depending on the particular provider. But you're, putting your data in a, out there in insert whatever person's cloud or, in your private cloud, but then you don't own, again, the IP that you created. And one of the things I think I really like about Mosaic, and this was sort of Palantir's approach as well, was the sort of the fine tuning infrastructure, the customer ends up owning and having access to, again, the results of the model and the weights. And I think that, yeah, I'm curious if, you guys see a lot of the sort of these like fine tuning workflows, how you see the direction of them moving. Oh, please, yes,
May I?
please.
So I have a very strong opinion on that.
Good.
So because that goes back to my previous point, right? So the model is stateless, right? And if you build a business around something that's stateless and digital, that's hard. So an example that I often give is like MP3 files, right? So you can compare like the hearings that were recently here in the US on AI with actually the hearings back in 2000 with Napster. Because the thing is, if you have an MP3 file and you copy paste the MP3 file, you have value twice, right? But you're not capturing value twice as a business. If you build something that is stateful, a vector database, for example, then no, but on a serious note, then the value is created by what people add to the database, right? So to your point, what I find very interesting is that the problem you have as a business that makes models is that the thing that you output, like the bread you're baking, the sausage you're rolling, whatever you call it, right? That's like a stateless thing. So you somehow need to keep control, like think about the music industry, keeping control of the MP3 files or whatever they do to stream the content to you. You somehow need to keep control to not basically give away the value of your business. And so that's like an unsolved problem, not only for models. That is an unsolved problem for any digital product that is stateless.
There's always been my sort of bone to pick with model providers is, what are you buying? Are you buying the weights at a particular point in time? Are you buying the rights to an accuracy in perpetuity? Are you buying, right, the promise that you get certain performance guarantees over a particular point in time? And I've always struggled with that question across, all different AI domains with respect to model providers.
Is it different in the open source community, Harrison? Like if that question that Angela was just raising of like, are you getting sort of a snapshot of capabilities or, something that you can actually own or improve yourself? Like, is that something that is trying to be solved by the sort of faster pace of, model development and sort of, improvement coming from open source, or what would be that kind of perspective?
I mean, I think there's definitely the like open source versus closed source.
Sorry, that's me. Sorry. Doesn't want me to sit that way.
I think there's like the open source versus closed source model kind of debates and battles, and I'm sure Jonathan can speak kind of like more eloquently to that than I can. I think like I think like a lot of when I started LangChain, I thought it would be kind of like a data scientist and ML kind of like tool, and it quickly became apparent that it wasn't. It was more kind of like a general software engineer. And I think like part of that is because of these private models that were accessible behind APIs and had pretty good uptime for everything, and were really good and stuff like that. And to me, like I think like when, and this is maybe, there's different user bases, but if I look at a lot of like LangChain's user bases, I think a lot of the people want to build applications using this as technology. And I think in being able to kind of just like use it as an API and not have to worry about hosting is a real enabler. And so I think like there are downsides to that, right? You don't have control over it. If you fine tune it, you don't own those weights. But I think for a lot of people who are wanting to create applications that are more cutting edge and utilizing a lot of these things, the fact that there's this incredible new technology behind this API that's so easy to access is a real enabler. And so I think also part of this has to be a discussion around like, yeah, like there are, like Falcon has been released, but like how easy is it to use Falcon behind an API compared to like OpenAI's API? And I don't think it's at the same caliber yet. And so like, I think like that is like, in terms of people building in the open source, that like a lot of people just care about ease of use and using it as a tool, and having it behind an API is a huge kind of like motivating factor for being able to get started really quickly. And I would love to see kind of like changes that make it more easy to use these open source models, because I think there's a real power to being able to get started in an open AI like way, and then say, hey, you know what, I want to fine tune this model and I want to have that as an option. But getting the best of both worlds seems a little bit tricky at the moment.
actually curious what you think then about like Amazon Bedrock, right? I think this is trying to become, the one-stop shop for open source models, other models, but behind, an easy to use API. I don't know, excited about that coming out?
Yeah, I mean, I think in general, like a lot of the knock on private models is that you have to send it behind an API and you send your data somewhere else and stuff like that. And I think like Bedrock, as far as I understand it, kind of removes some of those concerns by allowing you to deploy it within your VPC. And I think I'm generally, I think there's huge incentives for like Microsoft and Google and Amazon to figure out how to let and like basically people use these new models from OpenAI and Anthropic and Palm and all that without having to worry about privacy concerns. And I think they'll invest heavily in letting people do that. And yeah, I don't know if Bedrock is the most accessible for kind of like the average kind of like Joe developer, but in terms of like an enterprise who wants to utilize the best LLMs, but still have the option, or I don't know exactly know what the fine tuning things are, but at least avoid the privacy concerns. Yeah, like I'm pretty bullish on that as kind of like a solution for that.
Those are two different things, right? So, so Harris and I had a beer before this, and we talked about this, right? So the UX, I think nobody in this room disagrees with the fact that an amazing UX that you get through an API is something we do not want. I mean, is there anybody who just likes that it's like not easy to use? Okay, check, clear. And so, but the interesting thing I find from the model is the thing is you can't give it away. You can't, even if you want to, right? So even if Sam would walk in the room right now and say, listen, I want to give it away. We're gonna just download it here. It's in the S3. Your words. From a business perspective, that's so hard to do, because then let's say that the model would be stateful, right? So that if you would download Falcon, that it would change based on the questions that you ask it. You can do that, because if that would be the case, then you could do that with GPT-4 tomorrow. So I find it fascinating that the UX argument, 100%, no disagreement. I 100% agree with that. But the thing is that OpenAI is, for example, or other companies are very well-funded companies. And it's just very hard to just give them all away, because how are you going to capture value from the thing that you're going to create with that model? And that's why I give the example of databases or Excel, right? The fact that Weaviate can be open source, or LangChain, that it can be open source, is because people use it in different ways to create value, right? So the database, it depends on the data that you add to the database that it becomes valuable, because it's stateful. But that is just not the thing with the model. So I find it fascinating that, again, 100% on the UX element, but the thing is if you try to create a business with the models, you somehow need to keep control over it, because otherwise then, like MP3 files, it's just everywhere. And everybody can see.
Some people would at least like to believe that this kind of democratizes, and you don't need a huge model to get business outcomes. You don't need to necessarily raise, $1 billion in GPUs, which like Inflection just did, with NVIDIA, where a lot of the money they raised didn't even come in cash, right? It came in compute credits from Amazon or someone else, in this case, Microsoft, and it came in chips, in this case, or GPU clusters from NVIDIA, right? And so then I think Larry Ellison announced Oracle's going to spend billions of dollars on its own H100s. Are we in this kind of arms race that is undemocratic or sort of centralizes things, because it really is just kind of dependent on a few people who can build the largest LLMs with the most H100s? Or are we in a moment where maybe, small models can compete, you can maybe stitch together your own stack, and you don't need to play nice with Sam Altman? And I want to give you guys credit. We made it over 20 minutes without saying his name. So good job. But yeah, Angela, maybe do you want to start, or yeah?
I'm a big open source fan, though. I think, everyone in the room would agree that like the best model out there is, GPT. now for, I guess. But what was that? There was that paper that just, that relatively came out, I think it was by Berkeley, that actually did a deep sort of quantitative analysis around the distilled models or some of the open source models compared to some of the closed source providers that said, actually the performance guarantees were not quite what was advertised, and that as some of the sort of fine tuning happened, a lot of their sort of efficacy with respect to some of their other tests actually decreased. And so that they weren't sort of this like magic solution that was promised. That being said, I think a lot of the benefits that you get over like finer control of the data that goes into your model, again, this democratization of, the open source community and the research community is constantly making advancements and pushing things out there and making all these different improvements. I want to run things on an edge device or on my CPU or on whatever. That it's just exciting, and that the sort of the pace of innovation that you're seeing out there and the companies that are spinning up is, relatively, again, it's sort of semi-unprecedented. So I think they're like, that's like, I guess, like the nature of capitalism though, right? Like people with a lot of money buy the best things and feed the beast. But like, I think there is again, a real value in some of these open source models, and I'm a big fan.
But even aside from open source, I'm
Yeah.
curious what you guys think. Just you all are working in the startup
Yeah.
ecosystem, and I assume it's a very exciting time in some ways. But are you also living in the shadow of the LLM giants, where kind of they dictate a lot of either the pace of innovation here or how we get to end outcomes? I see, John, you're shaking your head no.
One is I'm getting signs that we should hold the mic closer to our mouth. So we are language models that can now be heard. And now I forgot your question. What was your question?
I was saying, you guys are all working at what are relatively small startups compared to, let's say, Microsoft, OpenAI. Are you operating in their shadow where, there could still be seismic changes coming from them that you all have to react to? Or is this a time where you can build, kind of freely?
Yeah, I'll give a cheeky answer first, which is that I've personally risk mitigated and that my partner works for Microsoft. But two is no, we don't live in the shadow of them at all. I have a huge amount of faith in the open source community to build out tooling, but also to build out, manageable large language models, to Angela's point, that, operate on the edge or that operate on the CPU, right? Like my Mac, my M2, right, runs a bunch of different LLMs on it right now. It couldn't do that 6 months ago. Who knows what 6 months from now is going to bring. It is cool to see, no doubt, what GPT-4 can do and what Google can do when you have infinite compute and you have infinite engineering. But I think for most use cases, you're not going to need that much power.
Mike,
And I'll hold it up.
we're going to be good this.
I think the risk though, for a lot of some of these companies, that if your infrastructure, if your architecture is not model agnostic, then you 100% are at the whims, right, of, insert whatever model provider that you're using. Like if OpenAI decided to rate limit everyone all of a sudden, or just like turn it off, or to fundamentally change the way they structure sort of their internal prompts, right? All of the workflows that are built upon all the special prompts that people have been curating, all of the applications that people have been selling, like people have to be ready for that, right? Maybe I'm just a little more pessimistic, but.
No. So I agree with what you're saying, but like disruption theory is a thing, right? So can I ask the moderator a question?
It depends on the question.
How is the vector database that AWS creates called?
I can't tell you that. I don't
Me
know.
neither,
Yeah.
because it doesn't exist,
All right.
right? So the thing is, you can create stuff, right? New stuff is happening. We see models, LM models being ported to like C++. Talking to the people here in the room, there's a lot of opportunity to innovate and create amazing, cool stuff. Yes, it's true what you're saying, like it's very, costly to train, et cetera, but there's so much uncaptured potential and opportunity. So, so I agree absolutely with what you were saying, but I want to make sure that everybody in the room here is like, sees the opportunity to build amazing, cool stuff. I know a few folks who are doing that. but it's like I just want to have that set, right?
Of
It's not a,
course, yeah.
it's not gatekeeping, right? There's like we can build a lot of great stuff.
Well, along those lines, and Harrison, feel free to answer first. I do think maybe we could talk a little bit about the actual exciting uses of all these tools. I know we have a lot of infrastructure expertise here and kind of developing an optimal stack to actually use the LLM, but to what end? Like, to what actual value? Because at the end of the day, people actually have to be getting more money or like more joy or something out of actually doing all this. So maybe that will take us to your happy place.
Yeah, I mean, I think I think related to like both those past 2 points, like I think the only thing that I know, so to speak, is that it's like really early on in this space and it's like really fast moving. And so like, yes, like I think, and this, I think this speaks to both, like, you know, do we have like, is OpenAI kind of like this, is that affecting everyone's kind of direction? Yeah, absolutely. To some extent, they're absolutely pushing the pace of like what's possible. But then other people will catch up and other people will do other things and people will keep on innovating. And I think like the worst thing you can do is just be tied to anything. And I think that also then speaks to like what the applications are that you can provide value. And I think that's like constantly changing. I think like, you know, like right now, the limitations of a lot of these language models are that they're not like 100% reliable. And so I think a lot of the things that we see being built internally or like internal applications where, you know, like if you think about like what are the constraints of language models, they're not 100% reliable. Okay, so build applications where you don't need them to be 100% reliable or something like that, and leaning into that. And then as they get better, as like outputting, like, you know, okay, now you can output structured information. Great, it's amazing to spin up kind of like tagging and extraction and all these kind of like structured, kind of like extracting structured information from unstructured input or things like that. And so I think like,
Could you give an example of one that you've liked or you've seen without necessarily naming names, but just what that might look like?
for
For where it
across-
doesn't have to be perfect to be useful right away.
Yeah, I mean, I think like a lot of the internal chatbots over documents, like I think like chatbots over documents is almost kind of like, you know, it's almost a joke in how kind of like popularized it's become. But I think like that, like there's a lot of information that is easy to be searchable and respond to people like ChatGPT for a reason. And it doesn't need to be 100% perfect, especially if you kind of like cite sources and present it in a way where the UX is kind of like clear. And again, this is also the differentiation between internal facing versus external facing. External facing, what you were saying about brand, way more important than kind of like internal facing, where if something goes wrong, you can just Slack your manager or something like that. So I think it's like leaning into like those pros and cons. Another kind of like example of this is, and something I wish would be done more, is like really creative use cases of language models. So I think my favorite use case by far is like a dungeon master for Dungeons and Dragons of LLMs, because there it doesn't matter if the language model kind of hallucinates, it almost becomes kind of funny and part of the, you know, it's generating like entertainment. And so like I think like I don't know, like the limitations of language models are they're not perfect. And so trying to figure out some of those applications can go a long way. But again, they'll become perfect. They'll keep on changing. Like I think having that as like a fixed stake in the mud is like the most silly thing you can do at this moment. Like I think you have to be kind of like constantly adapting and seeing what everyone is doing. And also on that point, one last point, like I think like, you know, we talk about OpenAI, but like, you know, I think you think like a year ago, like OpenAI would be considered an underdog compared to like Google or something like that. And they're moving faster than them and pushing the pace much more forward. So I think it's, you know, I think we're in an incredibly exciting time, and you don't need to be the biggest player to be pushing the pace forward, but you absolutely need to be paying attention to what everyone else is doing in the space and adapting accordingly.
Awesome. John, people are anticipating, you know, Bard continuing to improve, Anthropic dropping a new model pretty soon. And then of course, you know, GPT-5 is potentially looming, depending on whether you believe they really published it or not. Do these models pick up a lot of those weaknesses that we've kind of talked about, and sort of can they be more that one-stop shop, or do you think that, you know, people will continue to need sort of a suite of products and infrastructure to really get the most out of them?
Yeah, that's a great question. And I do want to say, I mean, it is incredible to watch the pace of innovation with OpenAI and with Google's projects and Anthropic and so on. So, you know, when it comes to monitoring for general forms of, for example, toxicity, OpenAI has a very good filter there. They're open about that. but it's very general, and they'll be open about that as well. So, we have a warm relationship with them and discussions with them. They want to keep it general, right? It's about a little bit of CYA, it's a little bit of just brand protection. But when it comes to, aligning an internal chatbot with company values or something like that, or truly understanding what sensitive data or PII means in the context of a particular task, you're still going to need specialized tooling around that for sure. Whether that is simply something like prompt engineering, or whether that's some of the products that, folks up here are developing, including us with Arthur Shield. I think we're going to need both of these as well. But no, the idea of like a foundation model just being a one-stop shop, I think is certainly not going to be the case. And I do want to say, like, for the point of, LLMs being incorrect sometimes, they are improving dramatically, but we're not going to have perfect machine learning models ever. And so we can make progress in this space forever, but things like hallucination and incorrectness are going to be issues, and also obviously issues with the augmented retrieval aspects as well. So like I can search incorrectly into my vector database and just get back the wrong information. The LLM can be GPT-10 or whatever, and it's still not going to be great if that's private information that I incorrectly retrieved. And so we're going to have all sorts of issues like that existing for a long time.
So we're getting short on time. I'm curious, because we do have a fireside to look forward to. Thinking about the future, what gets each of you most excited about where the category is going? Give us, a little bit of a sense of kind of what is getting you guys out of bed to keep working in this space.
I can kick it off just because I'm holding the mic. So Harrison mentioned agents a little bit. And so the idea of agents in AI has been around for quite a long time. And so depending on how old you are, this has been, a hot thing in the 90s. This has been a hot thing at various times in history. I'm really excited about sort of connecting non-myopic planning into AI agents. So, I give functionality to an LLM, it can go and call out to Wolfram Alpha or whatever, but putting together sort of like an optimal plan of multiple different function calls with, incorporating uncertainty in the responses and cost and things like that, sort of this traditional RL or even planning style of approach to AI, combining that with LLMs, I think is very, very exciting. And I think LangChain will be obviously very well positioned for that as well as every company up here. Yeah, so that gets me out of bed as sort of, ever moving toward the AI of my youth that really got me into the space to begin with.
I think there's two things that I'm really excited by, and if anyone here is working on them, I'd love to chat with you. But I think like one is on the line of agents. Like I think like that's really interesting, and specifically, I'm really interested in kind of like long running agents. So I think like most of the agents we've seen so far, you like try to fit into like a chat UX or something like that. And I'm actually extremely bullish on kind of like long running agents in the background, because I think it lets them be more accurate. And that's the biggest issue with them. And so it's hard to get that trade-off. Like there's a trade-off between accuracy and latency. And so like trying to fit that in a chat UX means you're generally optimizing for latency. But I think like long running in the background kind of like agents are really interesting to me. And then also long-term memory, basically. And I think like vector stores are an important part of this, but I also think there's a lot of innovations to be had here. I think like a really exciting paper was the generative agents paper that came out of Stanford that basically used reflections to basically add memory into a vector store and then kind of retrieve upon that. And I think like, I think building chatbots that have this long-term memory involves a vector store, but also involves some other components. And I think I don't know, I feel like there's a few kind of like just heuristics that are there at the kind of like waiting to be found, and that will go a long way. And so I'm really excited by that as well.
In the common theme, apparently, one of the things that I think is the most exciting is, again, this intersection of natural language is such an organic way for most people to interact with your systems. And so these advancements in allowing basically this nice union of unstructured and then now sort of structured information. So I want to, parse again across all different kinds of free text and, more free form style of information. But at the same time, I can now translate that into a query for a database or a line of code that can execute over XYZ. And so there's this intersection of structured and unstructured data with this, which is like, tool use workflow, these agent-based workflows, I think is extremely exciting. And it brings together a bunch of different, very neat components in the tech stack. Something I'm looking forward to. And you tell me if this is on the roadmap for
We have a
vector
request
database.
for a feature, yeah.
One of the things that, I've been thinking about a little bit is when information goes stale, right? And so either for also, regulatory requirements and, to sort of get ahead of insert whatever arbitrary legislation is coming, how people think about, information storage and retrieval and purging records and, when the context inside a model goes stale, right? And how do you make sure that the result that you're returning is, you're getting the most accurate information. So I'm hoping to see, or would love to see, in a lot of these vector databases, tooling built out around, retention and, all that stuff. So I'm excited.
I have an answer to that. So, but before I'll answer that, so I also have two answers to your question.
Mhm.
So the first answer is multimodal. That's like heads down, right? So the future of LLMs, well, they'll die. It's like multimodal, right? So, yes, exactly. I'm not going to try to, pronounce it after you. So the second thing that I'm super excited about is so when we talk about like, making stateless models stateful or similar thing, the same thing, memory for these models. I'm working on a vector database, and the way we do it is actually, I find it actually pretty ugly. So we like inject it into the prompt, and it works. But tightening the overlap, and I'll answer your question with tightening the overlap between the database and the model. And there's a lot of work happening there, right? So that we try to make sure like what kind of, so that there can be type of representations coming from the model and that only the database can ingest, blah, 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 etc. There's a lot of interesting stuff happening there. So from my perspective, the big thing that we need to solve is the problem of the models being stateless, because the majority of data that people use, like the example you gave, you need a stateful model to deal with it. The model needs to know what you're talking about. And that's coming from the integration from the database, the vector database with the models. And a lot of work is happening there, and that's a matter of time. That's just the
Does
kind
that
of.
mean you don't need injections someday, or?
I hope so. It's just I mean, it works, but it's like also kind of ugly, and it's like aesthetically. I mean, it's like it's so there's a lot of work that's happening, and but that's like it's blending what the models are producing. There can be like, I don't know, in the form of binary embeddings, that kind of stuff, but it goes even further, right? It's like a little bit related to what you said, Harrison, with the actions, right? So these JSON actions, right? It's a little bit based on that, where really the model starts to interact with the database directly. So and things that we have, if people are interested and you search, for example, for generative feedback loops, super exciting. So it's like the database starting to populate information into itself. So my answer is like multimodal, and the second one is like the integration of the model with the database. So that would be my answer, I guess.
Very cool. Well, we could keep going, but we're getting the hook, I believe. So you guys will just have to dodge the VCs and answer questions on your own now. Can we get a round of applause for all our experts? Thank you, guys.
Smile.
Want to take a photo of you? There you go.
Thank you again. Thank you, John, Conrad, or Alex, John, Bob, Angela, Harrison. Thank you so much. We are now going to introduce our second session of the night. Hold off. I know they're so interesting. I'm going to track them down as well. For our second session tonight, we have arranged a fireside chat with the chief scientist of MosaicML, who we're fortunate enough to know as friends and partners. Perhaps there's some news, something that happened to you all that you can share about. Can't imagine what you'll be discussing, as well as Arthur's own CEO, Adam Wenchel. This will go on for about 20 minutes for this chat, and afterwards, for those of you here, You're welcome to track down the panelists as well as Adam and Jonathan. For any questions, we encourage you to mingle, but without further ado, please, Jonathan and Adam.
I do want to say one thing right up front. Can anybody raise your hand if you're a NeurIPS reviewer by any chance? Raise and keep your hand up if you haven't finished all of your reviews yet. Okay, good. For those of you who are NeurIPS reviewers, your reviews are due in about 7 hours. So if they're not in, please get to work. Don't make me chase you down. Thank you.
Okay, is this on? We may have accidentally selected out some of our audience by choosing today, huh? For the
I mean, you know, I'm an area chair. I don't want to have to chase you down. So get your reviews in on time. Raise your hand if you're not a NeurIPS reviewer. That should be everybody but 3 people in the room. Come up to me afterwards and I'll take your email address, please.
Awesome. Well, thanks for joining us today, Jonathan. Yeah, so got to start with the obvious. Congratulations on selling your company. Very cool. That's a huge accomplishment.
Thank you.
And just, you know, the acquisition, I remember hearing about it. I wouldn't say I was expecting it, but then once you think about it, like Databricks seems like a, you know, very, very great fit for you all.
Yeah, I mean, I think we always said to ourselves at Mosaic that we wanted to be the Databricks of machine learning. I guess that's happened. It was, you know, we do like their business model. They, you know, they provide a managed version of open source stuff that's really useful to big enterprises, and we wanted to be like them. So it's really cool to, you know, now we legitimately get to do that. I think it is one of those situations where, you know, 1 + 1 = 3 in some sense. You take a company that's really good at managing data and is trusted to manage data for a lot of big enterprises. You combine it with, you know, a company that's, you know, getting better and better at building large language models custom on personal data. And, you know, we can do a lot of cool stuff together. It's going to be fun.
Yeah, that's awesome. And just to dig into that a little bit, like, you know, I think the you know, you tell me, but the core premise of Mosaic is that, you know, this sort of one size fits all model is not ultimately the best scenario. And the true answer allows giving people the flexibility to create sort of fit for purpose models on their data that do their kind of reasoning with their kind of knowledge. But yeah, maybe say a little bit more about how you all think about that.
Yeah, I mean, it's pretty simple. Our core philosophy is that, yeah, exactly as you said, one model does not fit everyone. And, you know, we have these great context windows right now, but I still don't think the models are utilizing them effectively. So, you know, with no offense to, you know, Bob out there somewhere, you know, given that he picked on me a little bit during the panel, you know, even if you can get 1 million tokens in a context window, good luck to have the model actually make effective use of those. So I think we're in a world where there is a lot of customization necessary, whether that's like you're working on proteins instead of working on text or working in a different language that isn't optimized for. You have an internal business process that the model may not know about, and you want that to actually be baked into the model, not just shoved into the context window. You know, there's a lot of reasons to customize, and, you know, we do a lot of work with, you know, enterprises. It's a lot of fun, even though it's not as visible to the community. I think, you know, it's been more impactful in the world personally. And now we get to do that with Databricks' entire customer base. So we're really, really excited about that. I can't wait. Like, we weren't looking to sell, but, you know, when this kind of opportunity came around, it was hard to say no.
And so I'm curious, like, you know, given that in 2023, in July of 2023, like, realistically, real talk for a second. I know you're you know, you're someone who shoots straight and tells it like it is. You know, how hard is it to train an LLM yourself with the kind of tooling? And then over time, how easy realistically can that get?
I think the hard part of training an LLM is no longer training an LLM. Getting all your data in one place is a lot harder. Figuring out how you're going to evaluate that LLM so you even know if you're successful is a lot harder. At this point, training is easy. And I can say that personally. I haven't written a line of code since I got to Mosaic, but I've trained a lot of our big models recently. It's been a piece of cake. I check on them, you know, once a day to make sure they're not dead. They're never dead. You know, they just keep on going with no intervention, but I like to check anyway because GPUs are expensive. And otherwise, like, you know, we just released our 30 billion parameter model. I believe we're dropping another model tomorrow, actually, that should be, you know, much improved. And, you know, we're just going to keep dropping models every couple of weeks going forward. It's easy. I just train them on spare GPU cycles when I have time. You know, when they're idle GPUs, the jobs automatically kick off and more stuff happens. So honestly, now that we've got our evaluation in place and our data is in place, it's easy. The hardest part is getting your data in place. And, you know, that's what Databricks is about for us. And the next hardest part is evaluation. And if you know anybody who's good at monitoring models in production, you know, you should probably chat with them. And then The training is easy.
I may know some people. Let's talk afterwards.
Oh, really? Really?
Yeah. And we also share your philosophy. We, as much as possible, we try not to let the PhDs write code too. So it's never a pretty picture.
I mean, Jacob, I don't know where you are right now. I'm sorry in advance.
All right, so moving on, changing topics here. You got a couple big announcements that I wanted to talk to you about. So one is the release of this, you guys have released several open source models, including a 30B model. Tell us about that, like what went into that, and also sort of where is this going? Like what's next after this?
I mean, the 30B model was honestly boring and easy. There was the only drama was that we had customers who kept wanting the GPUs, so we kept having to pause the job, because apparently making money is important or something like that when you're a business. So they tell me, I don't know, honestly, it depends on the startup that's out there right now, whether making money is actually important, but I was told it was. And so the biggest challenge was we kept having to pause the job, move the job, change the number of GPUs because we had paying customers who wanted those GPUs. Eventually, we even moved it to H100s, which was incredibly exciting. I'm training a bunch of models on H100s right now, including the one that's coming out tomorrow. So it's just going to keep coming and they're really fast. But honestly, it was drama free. We just did the same thing as the 7B model, made the model bigger, changed the learning rate a little bit, and let it cook. That was it. And you can do the math. If you try to think of a pattern, first you have 1, then you have 7, then you have 30. What comes next?
When are we going to see that 1T model?
I mean, you can do the math. You can extrapolate now. I think if you extrapolate, it's probably like, early October. I'm not promising a 1 trillion parameter model in early October.
You heard it here, guys. October, the 1T
God.
model's dropping.
Well, it was nice having a job while it lasted. But no, I mean, we're going to keep getting bigger and especially getting better. Bigger is not always better. A lot of our philosophy at Mosaic is being able to make things more efficient. We're referring to this entire family of models we've released as MPT-1, kind of same architecture, same hyperparameters, same training set. What comes after MPT-1? You can do the math. And so we're kind of rethinking everything from the ground up. And that means a whole new family of models. That means, a 7 billion parameter equivalent model that's way better than anything that's out there at 7B. It's a 30B equivalent model that's way better than anything out there at 30B. And again, I say equivalent in terms of budget, because the way the parameters are actually used, you can get pretty creative. I think there have been a bunch of comments on what GPT-4 might look like. They're really creative ways of using those parameters. Palm is not, a parameter is not a parameter anymore when it comes to Palm. So lots of ways of getting creative, and I hope we'll have some new artifacts for the community soon on that. Tomorrow is not that, just for the record. We did not create a whole new model family and train it in the past 4 days. I took a couple of days off for the 4th of July.
Those GPUs keep working though. That's the thing.
Oh, that's the great thing about GPUs. You don't need to give them healthcare. They're more expensive than a person, but they do work 24/7. So, it kind of balances out in the end.
Yeah. So speaking of those GPUs, the other big announcement you all made recently that I was like super piqued by is that you recently made some announcements about some of the performance running your training jobs on AMD. And for, I think a lot of people probably know NVIDIA has been by far the dominant player in this space. And there's been a number of attempts to have sort of a credible a second credible entry into the space. And they really, none of them have really been able to get full momentum, but is AMD finally kind of breaking through as a credible alternative?
AMD has broken through. I mean, AMD has broken through apparently for at least a year, and nobody bothered to try, I guess, including to some extent AMD. I think we had to kind of, and I say that seriously because AMD's accelerators are really great at floating point 64 performance, which is really important for scientific simulation. They're really popular and AMD's making a lot of money, but it's for supercomputers for science. So AMD has not had to get into the AI market to do well. And so I don't know if it was the biggest priority for them because they're doing exceedingly well, just in a different market that people here don't care about as much. The new NVIDIA GPUs, other than the A100, are not very good at floating point 64 performance. NVIDIA sacrificed that for floating point 16 and now floating point 8 performance, which is why I think you see AMD dominating some of the scientific supercomputer spaces. But they've got their software together. It took a little poking from us for them to bother because honestly, they're making plenty of money doing other stuff. But AMD is here. We worked with them. Honestly, it was pretty quick. We just ran our stack on their stuff. They had to get a couple software libraries right. And things ran. I think it was, we calculated with a good flash attention kernel, it should be around 90% of an A100 on an MI250X, which is awesome. And MI300 is right around the corner. That's supposed to be the H100 competitor. It'll have more memory and a shared CPU, GPU with a shared memory space, which is much more similar to the GH200 than it is to the H100. So honestly, we have credible competition. I think there are actually 4 players in this space right now, and you should keep an eye on us because, you know, AMD is not the only partner we're working with to test out hardware. And I think we have a lot more options than people would take right now. But our stack runs today on AMD. You can go do it.
So more options for that like VC to startup to hardware to
Oh, yeah,
GPU
yeah.
company pipeline that we're
It's a
seeing.
great
Yeah.
time to be one of those 4 hardware companies. But hopefully we'll have some competition, and that means less money goes to hardware and more money goes to great models, which is awesome for all of us.
Yeah, very cool. So last, I don't know how are we doing on time? We have time for a couple more? Yeah, funny. All right, cool. One of the things I'm really interested in is we were talking about this a little bit earlier with, and you and I have talked about this before, like with the race to kind of bigger and bigger models is great. You mentioned there's also an efficiency play, but at some point where I think as you characterize it, everyone's climbing the same ladder, right? And are we sure this is the right ladder? Are there other ladders we should be exploring, other options? Does the current notion of what an LLM is that going to be where we wind up 2-5 years from now?
Definitely not, but if I could tell you where we were gonna end up, we'd end up there in 6 months instead of 5 years.
You'd start a startup and sell for $1 billion.
I mean, maybe we should go back again and, any VCs in the audience? No, I think that what I encourage my team to do, and, members of my team are here so they can check me on this, is do some weird stuff, like get creative and push the envelope a little bit. We've tried with every release we've done to do something strange. When we released our 7 billion parameter model a couple months ago, we did this story writer version that had an ultra long context. It was nice to see Anthropic kind of copy us a couple of weeks later on using the Great Gatsby to illustrate what you can do with a 64K context, which is awesome. I mean, it's good for everybody. It's great for, if you're using vector databases, it's awesome to have a long context. But we tried that as an experiment and pushed the limits on it. For our 30B release, we did an experiment where we tried training on a longer context, but only at the end of training. That worked really, really well, and the model you'll see tomorrow is a product of that. For the releases we're planning later in the summer, we've got a bunch of other stuff we're trying right now. I can't tell you what it is yet because a bunch of it's not going to work. We'll release the stuff that works, but we are playing a lot. Even on the H100, traditional model architectures don't utilize the chip very well. Everything that we've done in the past few years is built for A100 or TPU. H100s are a really different chip in a lot of ways. FP8, many more parallel processing units that mean that you can't really utilize them well without a super wide model. The architectures need to change. So we should all be doing weird things. What's the point in climbing the ladder if you're just copying OpenAI? There's more to it than that. Doing strange things with data. There's just a lot of opportunities out there, and it's really sad to me to see everybody try to do exactly the same thing. When I look around at all the big models, Bard, Claude, GPT-4, kind of the same to some extent. And there's a lot of creativity and a lot of room to change things. People just have to be willing to take risks. I'm glad my team is taking risks. I'm really proud of them for that, and I hope more people do that too.
Do you think one of the trends I feel I've observed and have been in AI for a long time is someone finds sort of a successful ladder that works and that kind of leaps forward, and then everyone jumps on the ladder, and then they all kind of hit the wall at the same time, and they all struggle with that wall for a while until someone is, whether you call it doing a weird thing or taking an orthogonal approach to a problem, there's people start to experiment with sort of different things, and that takes a while to kind of for the right one to really kind of get momentum. But it's almost like you need that AI winner where everyone's stuck against the same wall for people to try those weird things and find new techniques. Agree or disagree?
I mean, now that I've been acquired, AI winter, whatever, but no, in all seriousness, I think, we may hit a wall, or we may just hit a point where, what's the point in copying OpenAI? They've done a really great job. Certain companies have to do it. Google has to do it just to do it. Anthropic probably has to do it because they've built their whole business model around doing it. But for the rest of us, especially those of us who are building or fine-tuning models, we don't have to copy them. We can do different things. And you're not going to differentiate your business if you're trying to build any LLM anything just by copying OpenAI, at least if you're at the infrastructure level like we are. You have to do something different. For us, the biggest differentiator is customization. GPT-4, if the architecture that's been talked about is the right architecture, is not built for customization. You don't want to fine-tune a 1.6 trillion parameter model and then deploy a private instance of that just for yourself. We've tried to do the math internally. We think it would probably take at least 128 H100s just to serve that model. You can go and do the math on what that would cost to run in an ongoing manner for private versions of those models. If you're just doing the last layers of the model, it's still going to be expensive. And so there's a lot of room for customization. That's our advantage. But for everybody else, there's a lot of room to do different things. There are a lot of interesting models that keep coming out that are different in various ways. And I think we've all gotten bored of yet another llama clone. Our friends at Salesforce did an awesome job training a 7B model on 1.4 trillion tokens. I don't think it got the credit or publicity it deserved because it came out relatively recently, and we've seen like 4 of those models. They did a particularly excellent job from what I could tell, but nobody was really paying attention at that point because been there, done that. And we have a bunch of great models that are relatively similar. So if you want to stand out, you have to do something different. If you want to have a business, you have to do something different. That's certainly been our approach at Mosaic. We don't have the resources OpenAI does, so we have to do something differently.
That's awesome. Yeah, and definitely necessity breeds ingenuity for sure. Want to touch on the earlier panel, one of the themes that came up, and I think at some point someone even said, would love to get Jonathan's take on this, but it's sort of the difference, the kind of where you see sort of an off-the-shelf model potentially with augmented retrieval versus a fine-tuned model versus a rolling something, training something from scratch model, and how that, what the kind of, is there one that's definitely better, or is it sort of like a right tool for the right job? And then also how that plays over time with there's some discussion of the vector database actually collapsing in with the model and sort of those sort of converging. How do you see that?
I think it's honestly big questions that we don't have any scientific answers to. And my answer to all this stuff is do the science before you make any claims. It's easy to make the right claim for one's business. I'm not going to tell you that everybody should pre-train their own models. I usually tell my customers, at least when my salespeople aren't around, so Connor, cover your ears wherever you are. Start with prompting GPT-4 and see if that solves your task. If you can do that. If your data is private and you can't do that, start by using a vector database or by doing, retrieval augmented generation, because it's cheap. If it works, great. If it doesn't work, it doesn't work, and then move on to the next thing, fine tune, and then do retrieval augmented generation. See if you can help the model. Pre-training should be the last thing you try. And if you do, you should start small, train a 100 million parameter model and just see if you're getting any more signal and climb that ladder too. The trick in any of this machine learning is start cheap and work your way up. It comes down to some fundamental questions about where we think knowledge and reasoning happen in these models or where we think they can happen. A vector database world is one in which we hope that we can fully decouple knowledge and reasoning. Reasoning can live in the model, knowledge can live externally, and the model can be reparameterized around new knowledge if we ever swap out that database. That's a really great world if we can pull that off. But I think there's still fundamental knowledge in the model that we haven't separated. We're certainly not training to separate knowledge from reasoning in any way. Then you have to make the assumption that, well, can the model do reasoning using its context? Can attention essentially reason to produce, new content? Can you stick all the reasoning and logic, or can you stick enough knowledge in there that the model can reason? I don't know. These are all open scientific questions. We don't even have a good definition. So to me, in the meantime, you have to work your way up and try things. We may have clear answers later as we understand this better. We may design models that allow us to explicitly do that decoupling. That would be amazing. That would really turbocharge vector databases, any kind of retrieval. It would mean maybe we need to train one model and all you have to do is swap out the data. I don't think we're there yet, at least if we're there, I don't think we have evidence to support that. But these are the kinds of questions that for the academics, the scientists in the room, these are the boundaries that one should be pushing right now. If I were in academia at the moment, I'd be working on that. That seems to be where there's an opportunity to really make things better, or at least make things easier to use if you could separate knowledge from reasoning in a more explicit way. Even when you do instruction fine-tuning, are you giving the model the ability to format its outputs in a different way? Are you giving it a different task? Or are you giving it new knowledge that also is part of a new domain? This whole task versus domain question, I think, is a big one right now. And the answer seems to be, it depends who you ask. OpenAI is paying a lot of programmers to do programming questions right now, nurses to do medical questions. That means that they're under the belief that new knowledge is important in the instruction fine-tuning process. I've certainly found that if you do generic instruction fine-tuning on a domain-specific model, it will do domain-specific instruction following. So is it knowledge or is it reasoning? Hard to say. And those seem like big questions right now for me.
Absolutely. And so I think brings us to another theme. One of the things that's unique in the AI world, or it's far more true in AI than other computing disciplines certainly, is the interplay between academia and industry. And so you're someone who came from an academic background, right? Is this your first ever startup?
Yeah.
First
yeah,
ever
this is-
startup.
This is my
So
first job.
This was
so
just a little like, you know, it's, yeah, just a little layover on your way to a
It's good to
faculty
finally have a
position.
line on my resume.
Yeah. Yeah, that's amazing. So this was just a little layover on your way to an academic, to a faculty position at Harvard, right? And then things kind of, have taken off. And so tell me, like, here's the question. What was like the biggest surprise working in a startup, over the last 2.5 years that you've been at it?
I mean, from this perspective, I've been ruined for academia forever. You know, quite frankly, I read, you know, to be completely direct, I read papers now and I'm like, who cares? Quite frankly.
Normally it takes people like 30 years in academia
Yeah.
before they hit that point. They have to get tenure before they like
No,
stop
I
showering.
got
and-
there, a startup got me there in 2 years. I look at my own dissertation research in all seriousness and I say, who cares? It was impactful and notorious in its own way, for those who are familiar with it.
The lottery.
Yeah, lottery tickets. I don't care about lottery tickets anymore because the practical impact is very limited. And I wonder a lot of the time why people are still working on that problem when there are real problems to solve. You know, it's worth being frank with ourselves about the work we do and whether it's valuable. And as we learn, we should do things that are more valuable. I look at a lot of papers these days as a reviewer and area chair, and you know, I kind of look at them and go, why are you doing this? In all seriousness, ask yourself what's important and what's useful. Being at a startup has been really valuable for me to get that sense. I don't think I had that previously, but there is a bit of cynicism we have in academia that we can make up an application for any science that we think is important. But are we being honest with ourselves about that? I'm not sure if I was during my PhD. And that's a lesson learned for me. Certainly it's something I tell a lot of PhD students when I chat about their research. Are you actually doing anything useful? It's a serious question. Do you want to get a job? That's now a serious question because the job market is pretty terrible right now. People graduating with PhDs in machine learning. As much as I'd love to joke about that, it's really brutal. If you want a job, you do need to ask yourself, what will people care about if they want to hire me? That matters. So it's, you know, it's a little bit bleak on that front right now, but it's certainly something that I took away from this experience. It's changed what I want to do in academia. It's changed what I think about in a really, really positive way. But it certainly ruined me for a lot of the problems I used to work on.
Yeah, it's true. I know there's been a big push in the US in public policy over the last 15, 20 years to get more basic science PhDs, American, because for a while, we weren't minting as many as other countries. And, but the career pathways were terrible. And the irony is that one of the themes I've heard over and over again is, people who went to get their PhD in physics or chemistry, I've heard that a lot of the PhD advisors, the advice they would give is like, look, do whatever you want for your dissertation. Just make sure it involves machine learning so you can get a job when you're done.
A large part of our team, I think, of the PhDs on our team, I think we have 8 or 9 PhDs on the research team of about 17 now. Until we had 2 people join us last week, we had 3 PhDs in computer science. The other 5 or 6 are in physics and neuroscience, mostly neuroscience. I think that's better training for doing the kind of science you have to do in machine learning than computer science is. So honestly, that's something I look for. I had great collaborators from the neuroscience and physics worlds during my PhD who taught me a lot about that view of the world and how to really think about these problems empirically, scientifically. When we have systems we don't understand, how to reason about them. That's something we're not trained to do in computer science. I love chatting with computer scientists who say, well, this is just a thing. Neural networks are things that we've created, so we should be able to understand them. And I don't take that view. Neural networks are things that come into being when we set the right initial conditions for a system, in the same way that us being here is, something that came into being as a product of setting the universe with the right initial conditions in motion. It's not a predictable outcome. It's an infinitesimally unlikely outcome, but it's a really interesting one if you get the initial conditions just right. And it's the same thing for the deep networks that we enjoy playing with. Computer science doesn't train us to do empiricism or think about things in a way where we don't have provable ideas. Neuroscience and physics, to my understanding, at least with the colleagues I've worked with, does prepare people for this exceedingly well. And I love hiring neuroscientists a lot more than I love hiring computer scientists.
Very cool. That was a good one. I think we're getting close to time, so that was maybe a good note to end on. But any final thoughts, any advice to other startup people who are getting started with LLM startups now?
I wish I had magic advice of like, follow these 5 steps and
It'd be so easy.
and Databricks will come by you as well or something. I guess now I can put in recommendations, but no, it's really,
Now you can talk about stuff like you know everything. That's
oh, yeah, I definitely know everything, clearly. No, I think the best advice I have is, it does take a lot of luck in addition to everything else, and it's okay to acknowledge that. This is not a process where you put in the right ingredients and you're guaranteed to get a good outcome. I feel really fortunate that this is my first time up. It is definitely not the first time up for most of the folks at Mosaic who have done startups before. A lot of people have tried and failed and learned. There's so much I would do differently if I started over. I'm glad that things worked out well for us. I'm glad things worked out well for a team that has worked so hard over the past couple of years. Again, I haven't written a line of code. Who do you think has done the work? It's an amazing team, but at the end of the day, luck is allowed to be a factor as well. And I think we got very fortunate in a lot of ways. And I hope everybody else, in addition to working hard, has that same fortune.
So this is like the lottery
No,
hypothesis.
no.
For startups.
No more puns.
Yeah.
I will say that one of my favorite things about the Databricks deal, for what it's worth, is that, technically I did all the lottery ticket work at MIT, and the Databricks lawyers have told me explicitly that at Databricks, we are not allowed to use lottery ticket technology, because there may be, lawyers are great. If the lawyers are still in the room from before, you're awesome, you're wonderful. But we are not allowed to use lottery ticket technology. So lottery ticket technology is owned by MIT and owned by the world now. I hope you all enjoy it. It is yours and not mine. And I hope it means that people stop asking me about lottery tickets. But lottery ticket technology, it's yours to do with as you please. I can no longer work on it. So have fun.
All right. Thank you, Jonathan, for coming by. Thanks. Are you gonna wrap?
Thank you, thank you. No, I just wanted to say, well, thank you, Adam and Jonathan. Thank you for the candor and the good questions and the thoughtful things. They'll be here in the room. But lastly, I just want to say thank you to everyone who joined us virtually. Thank you so much for tuning in. We missed you here in person. Please reach out to any of us if you want to continue the conversation, but this will now be concluding our virtual portion of the event. Thank you.